Thanks. Yeah, my name is Goran, and I'm just going to present a little bit about this very fun technology in my mind. But I just want to check, is there anyone that haven't heard about WebRTC here? With maybe raising hands, just to check, okay. So there are people that heard about it. Is there people that used it? There are a few people. Okay, so it's probably already familiar to you. I think this presentation is only going to be like the basics of how to start using it and what options do you have there to use. So WebRTC, it stands for Web Real-Time Communication. It is a set of technologies brought to browsers, so you can use your devices, media devices on your laptops or on your phones or your computers for communication purposes. So it comes in two parts. One is to actually access those devices from the browser. The other part is peer-to-peer communication and signaling. Yeah, right from the start, I will just show you how easy it is to just start up the camera, and I'm just gonna write some demo for it. Uh-oh.
It's time. Live demo.
Because it's quite easy. This is a basic scaffold for an HTML page, and I'm gonna create two elements. One is the video element, where that would be the sync of the video stream, and the other would be a button where I should start with the button, the stream. So if I make a video element, and in order for the stream to start playing right away, there's an attribute called autoplay, and then the button. I hope you guys see what's on the screen.
Yeah.
I was going to start the stream. Okay, and in JavaScript, go JavaScript. I'm going to write a function start that does the work for me. So the API provides WebRTC functionality behind media devices instance. So you go with navigator and media devices, and from there you have some capabilities here just for accessing the camera and also the microphone as well, and other media devices. You can use this one, get user media. So get user media accepts constraints. Constraints are descriptors of what do you want from the device, and it returns a promise with a media stream. Because it's an input outcome, you can expect it's an asynchronous request for the stream. So for the constraints, I will describe that I need a video, true, and I don't need the audio, so I'm going to set it to false. And in return, I'm going to get a stream, but because it's a promise, I'm going to await for it. That means this guy is going to be async. So with this code, I would be able to start my server. Let's see if I can zoom in a bit. So there is a video here that we don't see. It's blank, there's nothing. But if we start, I forgot something. I didn't assign the stream to the video element.
That's kind of important.
Yeah, it looks like, yeah. So I'm gonna get my video element with a query selector. And on the source object, I'm just gonna assign this stream. What about now?
Hey! Whoa.
Yeah, there's a camera from my laptop.
No permissions
From here.
requests from the browser?
Permissions. First time you access it, it asks you for permissions. But every browser has their own view of how permissions work. Yeah. So that's why I'm telling browsers can see you, and government doesn't spy at you at all. In Firefox, it would ask you for permission, I think, every time. And there's also some capability difference between browsers of how those devices are being described to the browser. So this is where compatibility comes into play. Your struggle if you're making a production application, you kind of need to think about the differences how the browser treats this thing for the user experience. But I'm using Chrome here. So I already played in my session with this application and recognize my domain. It says, okay, you can use it already, so it didn't ask me anything. Okay. So that's the basic example. From here on, you can use the video stream, and you can record it. You can put it in Canvas as well, and then overlay the video stream with something else. This is very useful if you want to make an application for actually face detection, and you just draw a circle on your face and stuff like that. So a little bit story time. In 2018, a company called Daon, that's an Irish-based company. They work in identity industry, in biometrics. They work with software that provides, let's say, identification with biometric devices. So you have deep fingerprint, you have retina scans, you have face detection, OCR with the documents and stuff like that. But WebRTC was officially already on all browsers in some kind of an experimental mode, and they wanted to pivot in that direction as well. So they can provide libraries also that use WebRTC, and that's when I was hired in that company and helped with making a prototype for it. For me, it was straightforward. Code that I wrote, it's almost the same as it was in 2018. And all I knew that we have two cameras on every phone, the front-facing camera, the selfie camera, let's say, and the back-facing, which is the environment camera. Okay, so you just need two scenarios. Use this camera for face detection, this for document, OCR, and that's it, we're golden. So, yeah, we bought most used devices and tried to test the prototype. Everything worked well. So my idea of the future of the camera is going to develop in this direction. But you know what happened quickly after. Phones competed with a number of cameras on the back. Of course, this is fictional, but is it? Yeah. There are. I saw some phones with like 6-7 cameras that use lens lenses and stuff like that to promote their photographic capabilities. But yeah, this is a challenge because now you have to deal with all kinds of companies competing in their different ways with cameras, and I need to do the OCR on a document, and not every camera is capable to, user-friendly for OCR. There was one scenario with a Sony device that has an infrared camera, and if I ask for a back camera, it's going to give me infrared, and I cannot use it at all. That's where constraints come in. You kind of need to be smart and figure out with your constraints what you want. And constraints, I'm gonna just quickly show how did I use it in code. Constraints is this part. When I ask for user media, I describe what I want. In this case, I just put video to be true. That means just give me a video string, and that's it. But this is polymorphic, so I could also describe it with the object and, okay, give me video stream, but I need it to be between this resolution, so this aspect ratio, or give me a specific specific device by device ID. I can show you how it looks like. So I can specify the device ID if I know the user has like a set of cameras. If I know the device ID of a specific camera, I can use that. Facing mode is useful when you want to direct it to use the selfie camera or the back camera. Immediately you narrow down the number of cameras there. Frame rates, height, width, this all depending on the capabilities of the hardware. You never know what it is, but if you put a number there, it's gonna try to grant the closest one that's capable on the device. Yeah, for audio as well, I didn't play around with audio that much, but there are some things here that can be useful for example, if you want to promote quality or speed with getting the audio, and this is good if you want to use the audio for recording and playback. Noise suppression is good for calls and echo cancellation as well. So yeah, this is a couple of examples how constraints are being constructed in an object and then can be thrown into the user media getter. And there is a heuristic how the WebRTC decides which of these have the priority. But you can probably just mention ideal in most cases where you instruct the library to just reach this goal. That would be ideal, if not just between minimum and maximum when it comes to weights or when it comes to other numbers here. Okay, so for constraints, I would like to actually simulate a situation when I have multiple cameras and I want to select one of them. So I can enumerate devices. If I go to Navigator, media devices, and enumerate, it will give me an object, a list of all the devices on my my laptop at this instance. It's also asynchronous, so I'm gonna await for it, and I'm gonna print it in console. I'm gonna stringify it. Delete the navigator there. So I'm gonna wait. I'm awaiting for enumeration, and in stringify I'm gonna make it a little bit beautiful, and I think that's it. It's a bit cramped here. So now I placed it inside of a start action, so yep. On my device right now I have 3 media devices, 2 are audio, I have 2 microphones, and 1 is integrated camera that's video, and that's the one that I'm using right now. But I also can add another camera. If I go through this again, I see there's more devices here. I have a USB camera here, and I have its device ID. So I can use this device ID in my constraints and just point to that one if I want to use it. So that would mean instead of video here, I will set a device ID. Like so. And I should be able that's the one.
Yeah.
Works.
Is it always the same ID?
Sorry?
Is it always the same ID?
Is it always what?
The same ID. That if you unplug it and plug it again.
Quite frankly, I'm not sure. If I try to reuse this over time, it's the same ID. I don't know if another domain opens it, does it change the ID? You cannot really rely on the ID. You need to enumerate, and what usually happens is like Teams or Google, what's it called? It's not Hangouts now, it's Meet. They would give you the first selection, but they will enumerate a drop-down where you can select another different one. And it might remember your last choice. I don't know how it works. But this is one of your choices you can make in your applications to decide how to use it. Okay, I can also share my screen over this WebRTC. Simple change, instead of getting user media, I will get display media. I'll quickly do that. So I just replaced get user media with get display media, and now Chrome takes over and gives me some options. Should I share this tab? Should I share some window, or should I share the entire screen? So I'm gonna share my Visual Studio Code now, and it got me back to Visual Studio Code. But here, in my browser, I can see Visual Studio Code. But yeah, you probably saw that you can share your screen on the web with those apps as well. This is how it's done.
So now you can stop sharing my password.
I'm not. Actually, I want to showcase another thing. You can apply styling to video streams. The styling choices are the same choices with images and other video media that you can use. So I'm just applying the filter on it. So if I get to my video here, I can add a style with a filter, and I have some choices here. What do you think?
Grayscale.
Grayscale?
Or privacy.
Let's try grayscale. Share my Visual Studio Code. It's not grayscale.
Nice.
You lose all your benefits of colors in Visual Studio Code, but
Vintage.
yeah.
Use Beam and then you're a pro developer. Yeah, exactly.
Yeah, that's the fun part of WebRTC. Now it's a bit more complicated when you look at how actually peer-to-peer exchange works. So it's to enable peer-to-peer, there's something called an ICE protocol. ICE protocol helps you navigate through all the barriers between two users, and those barriers are usually your net and your firewall. And one user by itself, your web app, cannot do anything about the position where your device is. So you kind of need to rely on external services to provide you with like a middleman to connect you with another person first. So this is done with ICE protocol. So it's an interactive connectivity establishing protocol. Generate major traversal candidates. So that means that you don't have only one way to connect to another user, or not. You don't really have only one solution to it. For example, you can pick between TCP and UDP for it, depending on the situation you are in. Firewalls, for example, can prevent you from using UDP on most ports, and that could be a problem. So it helps with traversal of candidates, which can be used in WebRTC application, which can be successfully sent and received through nets. So yeah, why it's not easy? I mentioned NAT router may be a problem, and also your firewall may be a problem. Part of ICE is STAN. STAN is the most likely way to resolve your problems. STAN is a server who talks with you and the person on the other side to identify yourself and help you establish a connection with a common, let's say, handshake. So behind that, you know that your address in your local network is not the same as the address on the web. So NAT tries to transform your local to the global one, or the one that actually works between the two in traversal, and tries to find the best way to establish that connection. Sometimes some server cannot do this. Usually the NAT has a capability of security capability, which is a good thing. That's symmetric NAT, which means that it doesn't allow connections to places where you didn't recently connected to. So when we're talking peer-to-peer, one side will always lose in this case. So in that scenario, you can use the turn server, that's a relay for your data, and that then your connection is not peer-to-peer anymore. It relays through another server, and it can cost a bit because it needs to transfer both sides, both bandwidths. And this is called a simple call, like the way you establish a call and start working on it. I never built WebRTC connection, but usually you have services to do this for you, and in WebRTC you use your own always how to transfer the data once your connection is established. And this is sort of a pseudocode. Not going through all of it, I just want to describe what's going on. So every party in this communication creates two peer connection, RTC peer connection. This is part of WebRTC instances. One is describing your own position, and the other is describing the other party. The one side creates an offer. The other side creates a response, and it all goes through the signaling service, the ICE protocol-enabled signaling service that we talked before. And then once you get an answer, then your connection is established, and in your answer you can start streaming your object the way we brought streaming in previous examples. We can start streaming through that second connection. And well, the first connection, the second connection, actually you receive the stream from the other side. Yeah. and I provided some resources. I think the slides will be available, so you can check out these resources, but all of these are also quite Googleable. The most interesting one from this list is WebRTC hacks, which I refreshed all the time while I was working at Daon 2018. The author is Chad. It's basically like hobby blog, but quite sophisticated blog with all kinds of examples how WebRTC is used in some like Google Meets or places like that, or how is it used behind WebAssembly and stuff like that. Yeah, and yeah, that's it.
Yeah.